Historically, building a mobile app meant doing the exact same work twice. You had to hire one team for the Android language and a completely separate team to build it from scratch for iOS. This diagram illustrates how Flutter solves that problem. It acts as a universal translator, allowing you to write your app just once. From this single codebase, the system automatically builds native versions for both Android and iPhone. Flutter provides the physical building blocks of your app. It gives you a box of high-quality, pre-made digital Lego bricks, like buttons, text boxes, and navigation bars. Your job is simply to pick the bricks and snap them together to design your screen. This graphic shows the division of labor. If Flutter is the visual exterior of the car, the parts you see and touch, Dart is the mechanical engine underneath. Dart is the programming language that tells the app how to process data and respond to user clicks. Understanding this separation between visual design and background logic is the foundational mindset you need before we begin configuring the workstation. Step 1 is getting the right tools. Your computer currently doesn't know how to build mobile apps, so we need to download the official Software Development Kit, or SDK, directly from Google. This image shows the specific zip file you'll download. It is critical that you do not leave this in your Downloads folder. You need to extract this toolbox into a permanent, secure directory on your C drive so your system has a stable path to the core files. Next, we update the computer's master address book, known in Windows as environment variables. By adding the Flutter folder path here, your system will recognize Flutter commands regardless of which folder you are working in. With the tools installed, we need a workspace. We install 2 programs for different roles. Android Studio is used for its heavy background utilities and virtual device managers. However, we write our actual code in Visual Studio Code, a lightweight, fast editor where we'll spend nearly all of our development time. Here we see the results of running the Flutter doctor command in the terminal. We are looking for these specific green check marks next to Flutter, Android Studio, and VS Code to verify the installation. Those check marks prove the system is healthy. The computer is now capable of compiling code, allowing us to move from desktop configuration to the physical testing device. By default, smartphones restrict the installation of custom, unfinished applications to protect the average user. To test our own software on our hardware, we have to override these standard security settings. This screenshot displays the software information menu found in your phone's settings. By tapping the Build Number field 7 times, the system will grant you access to a new menu called Developer Options. Inside that new menu, you'll find the setting for USB debugging. Switching this toggle to on establishes the bridge that allows your computer to send compiled code directly to the phone via a cable. Now we generate our first project. When you run the creation command, Flutter doesn't give you a blank file. It automatically builds a fully functional, pre-wired application infrastructure for you. Inside the project, you'll see folders labeled Android, iOS, and Web. These contain the native code required for those specific platforms. You will almost never need to open these. The Flutter engine handles them automatically. This is your active workspace. Nearly all development happens inside the lib folder, specifically in main.dart. Below the folders is pubspec.yaml, the master shopping list for adding images, fonts, and packages. The YAML file is incredibly strict about spacing. If you use the tab key or miss a single space indentation, the app will fail to compile. With the hardware bridge open and the project folders mapped out, the final step is learning how to communicate with the Dart engine. In Dart, you store information inside variables. Think of them as designated storage boxes. Every box needs a data type label, like string for text or int for numbers, and every line of code must be sealed shut with a semicolon. Next are functions. While variables store data, functions act as the machines that process it. They take raw inputs, perform a specific calculation or action, and return the result. This graphic illustrates classes. A class is an architectural blueprint. Instead of manually writing data for 100 different hotel rooms, you create one blueprint and use it to stamp out identical, populated data objects. But what happens if you create a box and forget to put anything inside it? In programming, an empty box is called null. In many older languages, if a machine tries to process an empty box, the entire app crashes immediately. Dart uses a protocol called null safety to prevent this. The system rejects any empty container unless you explicitly authorize it ahead of time. You do this by stamping the data type label with a question mark. Mastering these logical constraints makes your code predictable. By accounting for empty data early, you eliminate the most common cause of mobile app crashes before the user ever sees the screen. Now we see the results. Inside VS Code, with our phone selected as the active target, we execute run without debugging to start the compilation process. This screen confirms the success. The workstation translated the Dart logic, built the Flutter UI, and deployed the live application directly onto the external hardware. Because of the environment we've configured, this single code base is now ready to be deployed to an iPhone, a web browser, or a desktop without changing your logic. The toolbox is operational, the hardware is synced, and the engine is verified. You are now fully equipped to wipe this default screen clean and begin engineering your own custom application.